Alright guys, so we have a problem today that deals with the area of a sector, and this is a problem that generally gives my students a little bit of a tough time to figure out. So I'm going to go over the problem. There's two parts to this, A and B, so we'll start with part A and then move to part B once we've solved that. So the problem states that we have a house that is 47 feet by 33 feet, which I've shown here, 47 by 33 feet. We've driven a stake in at the corner of the house and have a leash running attached to our dog here. Alright, so if our leash is 15 feet long, part A wants us to figure out how much area the dog has to play in. So they want us to basically find the area of a sector. Now, this always gives students a lot of issue because they don't know what the central angle is. It doesn't tell us what the central angle is. We're not really sure. As we know up here, area, we need to have radius and the central angle. We've been given the radius. We need to determine the central angle. But what I always tell students is, okay, we have the dog on the leash. He's able to run as far as he can this way until he runs into the house. And he's able to run as far as he can this way until he runs into the house. So we do technically have a central angle here. If this house is a rectangle, as it tells us that it is, that means that the dog has a certain amount of area to play in because he is given a central angle that's going to be 360 minus this 90-degree angle that the house occupies. So our central angle is actually 270 degrees. And once you figure that out, this problem becomes a whole lot more simpler. So we have 1/2 times 15 squared times 270 pi over 180, or some of you might know from your unit circle, 3 pi over 2. So once we have that information, we can just plug it in. And if you enter that into your calculator, we have 1/2 times 15 squared times 270 pi divided by 180. We get the dog has 530 square feet to run around in. So 530.14, so about 530 feet. Now, part B says, all right, what if the owners say, well, that's not enough. We want our dog to have 750 square feet of space to play in. So obviously we can't change our central angle. There's a house there. So the easiest thing to do here is change the length of our leash. So for part B, they want us to find out how long would we need to make the leash, or the radius of this circle, to give the dog 750 square feet to play in. So this is much like some of the problems we had in the area of the sector video a minute ago. We know that area equals 1/2 r squared theta. We have two of our three variables. We have the area and we have our central angle. So we can use these. So 750 is going to equal 1/2 r squared and 270 pi over 180. Alright, so we just need to solve for r. So the first thing we could do is multiply both sides by 2 to clear my 1/2. So that's going to give me 1500 is going to equal r squared times 270 pi over 180. Alright, so at this point we need to divide both sides by 270 pi over 180. You could simplify that down if you wanted. Alright, so we got 1500 divided by 270 pi over 180. And so that's going to give us, I'm running out of room, so we'll bring this over here, 318.3, and that equals r squared. So if we want to find out the radius. We just need to take the square root of both sides. And so once you take the square root of the answer, you'll get that the dog's leash would need to be 17.8 feet in order for him to have 750 square feet to play in. 17.8 feet. So there you go. There's a way that we could use the area of a sector to solve a real world problem, giving our dog enough room to run around and play in. Thank you guys for watching. We'll see you next time.